Okay, we're going to go ahead and get started. Welcome to the Which Way Routing and Optimization session of the 2015 North Carolina GIS Conference. My name is Christian Forsland. I'm the GIS coordinator for the North Carolina Railroad Company. I'll be the moderator. Hopefully you didn't have trouble finding your way to the conference or this room, but if you did, this session and these presenters should be able to help you out a little bit with their content. We only have 2 out of the 3 presenters today. They will be focusing on getting from point A to point B and how time, energy, economics, and efficiency can be critical factors when moving people, services, and commodities. We had 3, John Wisdom, Scott Barnwell, and Dwight Outwell. John Wisdom has not made it here to the conference today, so we're going to start off with Scott. Scott manages the Asheville's enterprise business applications and oversees the city's open data program. Prior to joining the city of Asheville, Scott led a private GIS consulting team and also worked for the federal government. He is going to be giving a presentation on GIS-based sanitation route optimization. Please welcome Scott Barnwell.
All right, thanks everybody. Can everybody hear me okay is that good? Okay, I'll try to talk loudly. So I'm going to talk with you today about a project that we did at the City of Asheville to optimize sanitation routing. And just to give you a little bit of background on this, originally our sanitation group that works in our public works department was approached, or they reached out actually to a consulting firm that was that specialized in sanitation routing, and there was interest from the upper management to figure out a way to make it more efficient, to basically get more done with fewer drivers, fewer trucks, and just get the whole collection system done more efficiently. And so they were given a proposal to study and evaluate and offer some optimized alternatives, and it came with a price tag of about $80,000 to do that study. And quite honestly, they had the money budgeted, and they were going to roll forward with it. But we had a pretty good relationship, the GIS team and our sanitation team. So they came to us and they said, "Hey, do you think you can help us out with this? Because we know you do a lot of routing analysis and network analysis." And we said, "Well, let us give it a little bit of thought, and we'll come back to you and let you know what we can do." And so we went out and started doing some research. Like, we knew how to do route optimization using Network Analyst and other tools, but we didn't know a whole lot about sanitation. So we started looking at other agencies, other cities that had done similar types of studies, talked to some folks in Durham, North Carolina, who had recently completed a project, and also in San Francisco, California, and learned how different cities really have different issues, and sanitation routing is a lot more complex than it might seem. But we felt very confident that we could deliver something of top quality, so we literally put together a proposal, and I had a consulting background, so we just wrote up a proposal as if we were an internal consultant and delivered a scope of work, what the deliverables were going to be, a time estimate, as well as how many labor hours we thought it would take to get the job done, and presented that to our sanitation managers, and they decided that they wanted to give it a shot. They had a lot of confidence that we could pull this off. So that's how the project got started. And so there were really 2 big topics we were looking at. One was sort of the traditional route optimization, where you're trying to find the best route between a bunch of points. And the other one was, how could we balance workload between days and between trucks? So they're 2 separate issues, and I'll get into both in terms of the details of how we did that. But anyhow, we'll start out with route optimization. Let's see if this... Hold on one second. Where's this? You know what? I can just click through it, I think.
Yeah? Okay.
Nope, there's not an update there.
It's on that other screen.
Yeah, let me move that over. There we go. We're good. We got a second virtual screen up here that we can't see here, but it's here. So if I'm talking about something and you don't see it, just somebody say something. So anyhow, we started out with we defined what our project goals were going to be, and there were 4 things we wanted to do. The first was just to simply reduce the number of routes it took to collect all the trash in the city of Asheville. Secondly, we wanted to be able to balance that workload, so balance how long it took. So Monday's workload equaled Tuesdays, equaled Wednesdays, etc. So it was relatively balanced. We also knew that the data resources to actually analyze this, there were some problems, and we were aware of those and knew that we had to make some improvements to those. And I guess most importantly to all, especially to our sanitation folks, was we wanted to minimize the disruptions to our customers. Because people, I don't know about you all, but some people take trash very personally. And if you try to change everybody's trash day, people are going to be irate. And there's going to be calls going to city council like, why did they change my day to Tuesday? I'm a Monday. You know, they've been doing it their whole life and they wanted to stay that way. It's a very personal issue, believe it or not. So we had to minimize that. That was a key project consideration, was minimizing that disruption. And so to start out, if you've done network analysis, basically you've got a bunch of points and you're trying to figure out the best route to get between all those points and back to home, right? It's just about efficiency. UPS uses this, FedEx uses this, and in their case, they've got a bunch of customers they need to get to during the day. The algorithm's going to route them, and it's going to use certain parameters like favoring right turns over left turns, trying to avoid U-turns, making sure it considers one-way streets, might even go so far as have constraints like stay away from schools during morning drop-off and afternoon pickup because it's really busy and you run into traffic. So those kind of constraints you can build into a routing model and try to find the best route to get from one point to another. The difference between those situations and picking up trash is when you're picking up trash, you're going to every house in the city, right? It's not like the route is variable. It's the same route week after week after week. And that really does impact how you approach a problem like this. So the first thing we did, and I'll be honest, as GIS professionals, we came into this with the assumption that we know software, we know data, like we're pretty smart people, right? We're collectively pretty smart people, right? So we thought we could show these sanitation guys a better way. Like we were going to teach them how to drive their trucks more efficiently, right? We learned our lesson on this. So we started into the route optimization, and we actually ran the analysis. We built this network model. We put together all the information about constraints, speed limits and the right turns, all that. We had a really good street network data set to work with. That was key. But we then went out and so we ran the model for certain truck routes. So here's just 3 sample truck routes in our sanitation system. But then we also went out and looked at the actual odometer readings, and we compared them. And it was really fascinating. We thought we were going to outperform. We thought the computer could outperform these guys that drive the trash trucks every day of the week. Well, on average, it was a wash. It really was about the same. And in some cases, the drivers, like this truck 374 here, they were 12 miles shorter collecting their whole route than the computer model said it should have taken. And there really was no good explanation other than that they were just doing a really good job. In a couple cases, the optimized route would be a little bit shorter, but overall, it was a wash. We realized we weren't going to eliminate any routes by doing this kind of route optimization. And what I mean by this kind of route optimization is like turn-by-turn directions. We were not going to get any efficiencies by doing that with trash collection. And we learned this because we went out and actually did a lot of field data collection, which I'll get into in a moment. But if you go ride in a trash truck, you will be amazed at the level of skill and at the level of competence of these drivers. And again, unlike those UPS drivers or the FedEx drivers where their route changes every day, these guys drive the same route week after week after week. And they internally just optimize that thing in their head. And they get to know these routes so well that they are extremely, extremely efficient in actually how they drive those routes. And so we learned that pretty quickly and realized this was not going to be the place that we were going to optimize or save, limit any routes. So we turned instead to route balancing. We thought, okay, and we learned this was actually a customer, or not a customer, but an agency out in San Francisco that had also gained a lot of advantages by looking at route balancing. So here's our current, or the system that we started with. And you might know this is the average hours per day that a truck is out on Monday, Tuesday, Wednesday, Thursday. So it's a 4-day work week, and to collect the whole city. And you can see where they collect over there on the map. And just looking at this, you can see that Thursday, they actually spend quite a bit longer, almost an hour longer per truck than they do on Tuesday. So it's relatively imbalanced. And they have 6 or 7 trucks out on any given day. So that imbalance is pretty significant, right? So the goal was, how could we balance these things out? And in order to do that, we had a big problem that we had to solve, and that was what variables impact how long it takes to collect trash on any particular street. How could we model trash collection on any street in the entire city? Like how could we predict how long that would take and predict it accurately so that we could actually make some changes here and balance this thing out? And that wasn't easy. There's a lot of variables that could come into play. Anybody have any idea? Any ideas what would impact a trash truck's ability to or what would cause it to take longer or faster? Townhouses versus normal homes. So sort of the density of where those cans are. Right. That's a good one. Anybody else? Yeah. What's that? Snow. Yeah. We did not. We did not try to deal with snow. We left weather as a constant, but that is true. Yeah. Holidays. Yeah. Holidays could definitely impact and the impact with holidays is a little different because people don't put their trash out that week, so the next week is going to be a lot heavier. Right. That's true. What about just in terms of streets and the way that your city is laid out? Left versus right, yeah? Having to turn around. Yeah, that's a big one. Like if you have to do U-turns or
Street widths in neighborhoods you don't have a lot of driveway space.
Street widths in neighborhoods without driveway space. So yeah, like a big suburban neighborhood where the streets are real wide and they're really spaced out versus a really tight downtown neighborhood where there's very few driveways or yeah. Topography, that's an interesting one. So like if the streets are really steep, or is that what you mean? Or it might be difficult. These are big, heavy trucks, right? It might slow it down. That's an interesting one. Cars parked in the road, which would really be tied back to the type of neighborhood, maybe like a dense downtown neighborhood versus a suburban neighborhood. But absolutely, that could impact things.
The way people, their patterns of getting rid of trash in terms of how often those trash trucks will be specific date, they have to return to the landfill to dump because of
the volume of trash. That's a good point because we did have to build in the model how many trips to the transfer station. Because on average, it's 2 trips per day per truck. That's a very good point, and it can change. Sometimes there are 3-day trips, or 3-trip days, I should say, which can really impact things because that trip to the transfer station really adds a lot of time to their day. These are a lot of good ideas. Anybody else? That's pretty good. Yeah, there could be other factors like the speed limit of the road, or you guys got most of them actually. I think one that we looked at was the curviness of the roads, like roads that are really straight versus roads that are really sinuous and curvy. We thought that might slow it down. So we had to figure out, well, what factors really matter, right? And we couldn't just say, we think it's such and such, because we did do that, actually. When we first sat down with the solid waste managers, we said, what do you think? And they said, well, that one neighborhood up on the mountain, that's going to be a lot slower, because it's up on the mountain, it's these steep roads. Somebody said topography. It's curvy. It's just a difficult place to get to. So yeah, that one's really going to be slow compared to these like tight downtown neighborhoods. Like somebody said, townhomes where the trash cans are really close to each other and they can just boom, 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 collect it really fast. So all these things we had to consider, but we had to put it into a statistical model to actually test for correlation values. Right? We needed a science-backed, data-driven approach where we could demonstrate correlation in order to model out what it would look like to balance the routes. And ultimately, so in doing that, we went out and did some field data collection. And we looked at there's 6 truck routes that we looked at throughout the city, which covered a lot of different areas. So we looked at some suburban neighborhoods, some downtown neighborhoods. This one up here is a real steep neighborhood going up a mountainside. West Asheville in the yellow over there is kind of an older, fairly dense neighborhood. So we looked at a pretty broad swath of neighborhoods, and we went out and literally sat next to the driver and rode shotgun in these trash trucks. And we took old school pen and paper maps, and we took a stopwatch. And for every street segment on all these areas, we would time how long it took to get from intersection to intersection, and also we counted how many cans were actually on the street to collect. Right, so we sat there and it was intense. These drivers are fast. I don't know what you think about trash truck drivers, but I don't know. Anybody have a stereotypical opinion of trash truck drivers?
I like mine.
He likes yours. I like mine too. I love them actually. These guys are amazing. I didn't know what to think. I really didn't have an opinion before, but I'll tell you now, if you ever get a chance to do it, like if you work for a city and they got trash service, go ask to ride with one of these folks. It's an amazing experience. So we were exhausted by the end of the day. These guys are doing all the work, right? They're driving the truck. They're trying to avoid cars at tight little neighborhoods. There's power lines overhead. There's tree limbs overhead. Trash cans that are put right up next to a car, and it's with a mechanical arm. So they've got a joystick. They got to control this arm. It goes out and grabs the can and dumps it and puts it back. And it's an intense experience. These guys are fast. And one thing that's really important to understand about the sanitation business. Anybody in the sanitation business here? Nobody? Really? All right, well, you'll learn something then. One thing that's really fascinating about the sanitation business that we learned is they use something called incentive time. I'd never heard the term before. But what that means is when a trash truck driver is done collecting trash for the day, they get to go home. It doesn't matter if it's 3 hours before the end of the day. They get paid for the whole day and they get to go home. That's called an incentive, right? And that really works. And so you go ride with these guys in the truck. I mean, it's amazing. You ride with these guys in the truck. They don't stop for lunch. They don't stop to go to the bathroom. They don't stop for anything. They just pick up trash. The only time they literally would stop to take a snack or maybe go use the bathroom would be when they got to the transfer station. If there was a line and they had to wait 15 minutes for the other trucks in front of them, they'd run into the porta potty and come back, eat their lunch real fast, and then they were back on the road. These guys do not stop. I mean, it's intense. And the managers of the solid waste division, they said this is how it works in sanitation. It's across the country. This is a norm. This incentive time, and these guys just bust tail. I mean, they want to go home and they work really, really hard. On the flip side, it's just kind of an interesting anecdote. It's very frustrating to like the public works higher ups because it's only in sanitation that they do this. So the other workers see this and they're like, "That's not fair. You know, why do they get to go home?" But the reality is those guys are taking all their breaks and they're taking an hour for lunch, going out to a restaurant. So it's a totally different world. But from an upper management standpoint, they're really questioning this. Like, why do we do that? And the reality is, and what anybody in sanitation will tell you, is if you take that away, suddenly these guys are going to be working overtime because the routes are going to slow down and there's no incentive anymore. And you can push them to the end of the day and then they're just going to take their time and get an hour of overtime every day because there's no incentive not to, right? So just a really interesting aspect of sanitation that really impacts the routing. And it also gets back to why the route optimization didn't work, because these guys are so driven to finish fast that they're constantly thinking, how can I do this faster? How can I do this faster? And that's why they can beat the computer. I mean, it's really phenomenal. They can literally beat the computer models in terms of how efficient they drive these routes. And having sat there with the clipboard, and because we would tick off every side of every street as we drove down it, it almost never happened. Maybe once or twice during an entire day that a truck would actually go up the same street it had already been up. In these old neighborhoods, it's not like a grid network. We're talking old neighborhoods in the mountains or mountainous areas. Some of them are dense neighborhoods, but they're just twisty, windy roads, and somehow these guys managed to figure out how to drive this thing without almost never would they go back on the same stretch of pavement they'd already been down. I couldn't do it. I mean, I was just blown away. But anyhow, they managed to pull it off. So, with all that said, there were only two variables that really mattered. Remember all those variables you guys were brainstorming a minute ago? We thought the same thing. We thought we were going to have this really elaborate data model and really impress, everybody with how smart we were. But at the end of the day, there were really only two variables that mattered. And that was the length of the street, which is nice because it comes out of our GIS database. We have that data for every street in the city, so right, that's really, really easy for us to work with. And the number of cans that are out for collection. Now, there's a couple points to think about here. One, it's the number of cans out for collection, not the number of cans in the city, because it's a different thing. We determined, and that's one reason we had to do those counts and actually count up how many cans were out on each one of those 6 routes that we went on. We needed to figure out what percentage of people put cans out every week. Because I know personally I put my can out every 2 weeks because we can't fill it in a week, so we usually just wait 2 weeks. I'm lazy. I don't want to walk out to the curb twice when I can walk once. And there's a lot of people like me that are a little bit lazy, and so they don't do that, and therefore not all the cans are on the curb every week. And we figured it was about 75%. So that was really important to understand. The other thing that we knew, though, was that there are about 30,000 cans in the City of Asheville sanitation database. We have a trash can database. We have a GIS. It's all geospatial, so we know where all those cans are. But almost 10% of those locations were missing. I don't know why, but that's how it was. So when we started working on this project, we realized almost 10% of those cans were missing, and we had to do something about it if we were going to have an accurate data model, given that was one of the two most important variables or most correlated variables to how long it took to drive down the street and pick up trash. So we had to fix that, right? So we went ahead and started this cleanup process. And Stephanie Osborne, who's in the audience, she did all the work here, so she's responsible for this awesome graph going down. So thank you, Stephanie. She and some other folks in Public Works worked together, and both through field work and office work. And they were basically comparing our utility billing database, which had all 30,000 cans, because they were all getting billed, right? We get the money for them. We just didn't know where they were. But almost about 9% were not located. So we had a record in the database. There was a billing address, but billing and service address aren't always the same. And so we didn't have an XY coordinate for those. So that's what Stephanie and some colleagues worked on. And over many months of very hard work and a lot of field work, they were able to drop that down and locate most of those cans to where we were about 99% accurate. And at that point, we were like, hey, this is pretty good. I think we're going to have a really robust data model for doing our route balancing. So that's what we did. All right. So here's this is how we make people think we're smart, even though it's really not that fancy. It's a lot of numbers up here, but essentially what this is actually another colleague of mine who's next door at the moment, Dave Michelson, who ran the statistical analysis on all the data we collected. And this was run through R, which is a statistics program, looking for correlation. And a bunch of, if you can read this, and I'll read some of them to you, but you all rattled off a lot of these variables like road type, speed limit. Somebody said the townhomes, that would be essentially can density, how dense the cans were, curviness of the roads, slope, somebody mentioned topography. So you guys got a lot of these. And we thought the same thing. We thought all these things could impact how long it takes to pick up trash. But in reality, when we ran this through a multivariate regression, we found that the only things that really mattered were the number of cans that were out, which these three things all sort of represent number of cans that are on the road, and the distance or the length of the street. So we had two variables to deal with. And at this point, having done that data cleanup process, we had really solid data to start our process of actually doing the route balancing. So again, our two critical variables here are the length of the street segment and the number of cans out per collection. And now that we had this, think about it. We've got this data. We've got 6 full routes of field collected data as our baseline with actual stopwatch values. So we were able to take that and interpolate out based on these variables. Every street segment in the city of Asheville, we can give you a predicted time for how long it'll take a trash truck to get from one end to the other and pick up all the trash on that street. And that's what you need to balance, right? That's the key to balancing these trucks, is knowing the workload, knowing how much time it takes to actually do the work. So it's less about routing in the end as it is about balancing. And so just to talk a little bit about the methodology of how we did this is really fascinating. And this was something we learned, again, from talking to this agency in San Francisco, because they had done a similar process. They essentially used redistricting, right? Anybody ever done redistricting work before for elections? Yeah, so it's the same exact idea. In redistricting, right, you've got people that you're trying to put into congressional districts or other kinds of election districts, and you're trying to create balance, right? And we won't talk about gerrymandering, but you try to create some polygons that contain roughly equal numbers of people to be in those districts. Well, we applied the same concept to sanitation pickup. So we wanted to take all those street segments that all had a now predicted time value, and we were going to aggregate those into like work areas or truck routes that would all balance out, because we could add up the time for all those street segments and come up with roughly equal amounts of work that we could send the trucks out on to actually complete. And in this process, we were able to eliminate 2 of our 26 routes. So that may not sound like it's phenomenal, but it was improvement. That means 2 less people that you're having to pay to be out on the road during the week, or really all week, but 2 less routes and also less wear and tear on the trucks. So over time, this is going to have some real benefit. And quite honestly, the Asheville sanitation system was already pretty darn efficient, and that's one thing we learned. I think the one thing where we were able to help was cleaning up that trash can database, and by doing that, being able to have a pretty robust model and find this little bit of efficiency we could still squeeze out of the system. There wasn't a lot there. Some systems can squeeze a lot more because they're just not, they didn't start in such an efficient starting point. So we felt pretty good that we were able to actually do some savings. So just to show you, this is the results, all right? So this is the current system as it is, right? And this is what, I showed you this graph before, but it's a little bit imbalanced. Thursday takes longer, Tuesday's the shortest. And after it was all said and done, the proposed system, you'll notice it's not perfect, but it's more balanced, right? It's within a half hour of each other anyways, each of those routes. Is there anything about those 2 maps that like jumps out at you when you look at those? What's your first impression? They're what?
Like the reverse.
They're the reverse. Not the bar charts. I'm talking about the maps.
The green section is one.
Okay, we got something
But
very.
the majority of it's the same pickup.
The majority of it's the same, right? In fact, when you first look at that, you might think, "Oh, that's the same map." If you look quickly and you didn't know what we were talking about, you might say, "But we've got some perceptive people." I'm glad to see we got. We're not having the afternoon lulls here. I thought people might be sleeping with all that food digestion going on, but we got at least one guy up here who jumped right out. He picked out the green area, which is
It's not just a second on the, got less time.
yeah. You see, like right along this little border right here, it's a little bit different. Sorry, it's a little small, but there are some small differences. Now, why do you think that's a good thing? Why would that be a good thing that we're not making many changes?
Because the drivers are already very efficient at where they're going.
Okay, that's one thing, but there's something more important than that. Those customers that are going to be calling city council to say, why the hell did you change my trash day? Right? We don't want many of those. We know we're going to get some, but we don't want many. So doing as little change as possible to get the desired outcome is really what this is all about. So if you think it's the same map, that's a good thing. In fact, there are some slight changes. And this is like a blow up of downtown, and these little blue areas are the actual spots that changed. They went from one day to another. And the chart over here shows you that some customers were taken from Monday and Thursday and added to Tuesday and Wednesday, right? So it goes Monday, Tuesday, Wednesday, Thursday. So Tuesday and Wednesday used to be shorter days. We add to them, we take away from the long days, and we more or less get balance. That was what we're after. And most importantly, in terms of the overall customer impact, only about 5% of our customers, to get this efficiency of eliminating 2 routes per week, for the rest of eternity, we're going to impact about 5% of our customers, which, at least for our sanitation managers, they were willing to deal with that many phone calls, right? If it was 20%, they probably would not have been too pleased.
It looks like about 1,500 people.
It's about 1,500 people, yeah. 1,600, something like that. That's right. So, and we send them a nice letter and explain that they're helping make a more efficient city and more effective use of their tax dollars. So we might mitigate that 5% and only get 1% of the people to call, but ultimately that's the goal. All right, so that's what it looks like. So again, here's that proposed system, just a little bit bigger. And again, it's not perfect, right? The balancing, and there's a reason for that. When you're doing balancing, or in this case, this redistricting operation, and we just use GIS redistricting, but when you do this, you can't just redistrict anywhere, right? This isn't like election districts where maybe you could have more flexibility, but both for the sake of the drivers and for the sake of the customers, you don't want to just add any random little street from one day to another. You want sort of contiguous neighborhoods to all be a Tuesday pickup or a Wednesday pickup. So you want to keep those areas more or less contiguous and use major roads, rivers, natural borders that you can be like, oh yeah, I live on the east side of Merriman Avenue, so my day's on Tuesday. It's just obvious. Customers get to know that and they understand that. So you can't just pick and choose, and that's why it's not perfect. We actually had to do some manual tweaking of the redistricting to get the best possible outcome without, creating really just weird little anomalies that would both, like gerrymandering basically. Because you could potentially make that thing totally flat, but you would have these weird little gerrymandered areas that would make no sense to the drivers and make no sense to the customers. So we thought it was more important to avoid that. All right, and I'm just going to roll through this real quick, what it looks like on a day-to-day basis, because we've been talking about the whole week, but again, each day you've got multiple trucks out, so you also have to balance the individual trucks on those days. So here's what Monday looks like, and you see it's more or less balanced. It's all a little more than 6.5 up to 7 hours, but it's within 30 minutes of each other. And here's the 6 routes here. Basically, it comes out to 6 routes a day. And here's Tuesday. Now this is an interesting, there's one thing that might jump out at you about, if you look at the chart here. Anybody see anything that looks a little unusual? Truck 4, right. So we're looking at both time, but also the number of trash cans that are picked up. Any guesses as to why number 4 would be so low? And does it matter?
Deadhead?
What's that?
Deadhead?
It's not a deadhead. Anybody familiar with Asheville? So this is truck 4 right here.
Yeah.
The Grove Park Inn is right about here. This
Yeah.
is Town Mountain.
Right.
So what's unique about Town Mountain? Mountain should give you a clue. Steep, narrow roads, right? Town Mountain's these long, steep, narrow roads, some big houses, kind of spread out. Fairly difficult to get to, really tight hairpin turns. So again, we know that the distance between one end of a street and another and the number of cans along that street are what dictate how long it takes to pick up. So in that area, you're going to pick up fewer per unit time. And so it makes sense your cans would drop off. Some agencies I've heard will strictly try to balance out based on the number of cans. They'll ask every driver to pick up 1,000 cans a day. Like that might be a goal. For us, we think this is a little bit more of an intelligent model because we know that not every can is equal. And so what we really care about is the workload. We want the workload to be equal. The number of cans really doesn't matter as long as the workload is equal. So that's what we were shooting for. you notice Wednesday, again, the time is mostly equal. Thursday was the most challenging day for us, and the map should give you an idea why. It's a really bizarre, this is South Asheville. If you're familiar with Asheville, this is the Biltmore estate right here, which has managed to avoid the Asheville tax base somehow. I can't imagine how billionaires could avoid being in the city tax space, but anyways, that's another story. So the city wraps around the Biltmore estate. It goes down south all the way to the airport. It's this long, contiguous part of the city. That's South Asheville. It's a long, big finger that sticks down. And that's a real challenge in terms of routing and in terms of balancing. So this couldn't be perfect without really causing the truck drivers to have bizarre routes that were disconnected. And so this was about as good as we could get based on the geography of South Asheville. Still better than it is. Or better than it was, I should say. So with all that, our project outcomes, we were able to reduce those routes again from 26 to 24. That was one of our original goals. So we felt, okay, not a huge impact, but a positive impact. The routes are balanced both day to day and also the trucks within each day. So that was really good in terms of getting the workload more or less equal. The supporting data, we were able to actually clean up that database. Thanks to a lot of hard work of our staff, we were able to make this thing 99% accurate and still getting more accurate as we go forward. But that allowed us to create a really robust data model to drive this whole process. And we were able to do that with minimal customer disruption. Again, that was a real key to the whole thing. And just to close, I just wanted to say, if there's anything we learned from this project, it was that you got to get out of the office, right? I mean, you learn so much when you get out from behind your computer and go out and experience the world with your customers. I have such an appreciation for trash truck drivers now. I would never want the job, but I sure appreciate those people that come down my street. They really work their tails off and do an amazing job and really care about their customers. Things like, just the very idea that we would give these trash truck drivers turn-by-turn directions. While in our in-office days prior to going out and riding in a trash truck, we thought it's brilliant, right? It's brilliant. We'll get a GPS and it'll bark directions to them all day long about where to turn left and right and so on. But the reality is these guys and gals are in these huge trucks with these hydraulic arms going over the top. They're manning this joystick. They've got a 311 application. If there's somebody puts a sofa out on the road to be picked up, they got to mark that with a 311 application so another truck can come behind, or also for brush collection. If there's a dead animal in the street, they got to stop and mark that. They've got to watch a video monitor every time the cans are dumping into the truck to see if there's any stuff that shouldn't be being dumped out of the can. So if somebody's dumping a body, they'll see it, right? I mean, you want to know these things, right? I mean, so literally they have my point is these people's attention is spread very, very thin, and they're trying to avoid all these cars and everything else. So the idea that we were going to give them these detailed turn-by-turn directions that would be like a mile long on paper, and they wouldn't be able to hear it if it was audible because there's so much noise in the trucks, and just the ability to concentrate on that is just ludicrous. And we wouldn't have known that had we not gone out. So we never even brought that up because they would have laughed us out of the office. But having been out in the trucks, we were able to learn that. And so we try to employ this principle now on every project we do is get out of the office, get out and meet your customers, talk to them about their business needs, where they're having problems. And because they were very suspicious of us, these IT people coming in the trash trucks, you can imagine they were suspicious on day one. But by the time the project was done, they saw us as partners, wanting to help them, helping to make the workloads balanced. They appreciated that. And they appreciated the fact that we appreciated them. I mean, because we told them that, over and over again. So anyhow, that's it. I'd be happy to take any questions if you have any. Yeah.
How long did it take you from the very initial decision to do it?
It was the whole project. It's been done now it's been 2 years, but the project actually took about 18 months to actually get the work done. And much of that, it was longer than we originally anticipated. The field work wasn't terrible. That trash can database cleanup, that was a lot of work. I mean, it was so much. It was a slow process, and it was coordinating with the public works staff who were actually going out and looking for these mystery cans that were in the billing database but weren't on the map. And so we worked with them, and it was just a really slow, iterative process. And at the end of the day, there wasn't a big rush on their end. They knew things were running pretty well. It was just an effort to make it a little more efficient. I was wondering, just thinking of it from a business standpoint, did we save the city any money by not having that consultant come in and do the work, the $80,000 original contract? having been in the consulting business before, I'm always like cognizant of that because it drives me crazy when cities are like, oh, we can do it for free, we'll do it in house. Because no, there's people like they're doing that work, right? So they're getting paid. There's benefits, there's overhead, and so I try to do a very conservative estimate of our time on this project, and I was like thinking at $100 an hour, which is like a billing rate that I would have charged back in the day, right? So, and I know we don't cost that much. We cost a lot less than that, unfortunately. But anyways, that's another story. But I estimated it was probably about $25,000 investment of staff time to do this whole project. But keep in mind that a big chunk of that was that data cleanup, and that was not in scope in that $80,000 contract. So we would have had an analysis done with 10% bad data.
So the consultant would have come back and wanted to mod the contract and get more money for it.
Either that, or they would have said, you guys need to do all this work. We would have been stuck doing it anyway. So, I'm sure they would have done a great job. Don't get me wrong, and I'm not here to say anything bad about that. It's just, but we had the skill sets in-house, and we were able to do it well, and we were cognizant of the long-term game of trying to get those data sets clean so that it could support ongoing work going forward. So, yeah.
But one of the things that you benefited that was not money savings, it was relationship.
Oh, the collaboration. Yeah, exactly. I mean, that collaboration and the relationships with Public Works is invaluable. It really is. And now they just call us up and come to us whenever just so you want to brainstorm an idea. So you're right. That collaboration is really important. Yeah.
How flexible was this project for growth in terms of population? So if you do subdivision, new house, new customers, how does that fit into what you've done so far?
Yeah, so that's a good point. And as long as that data is managed in terms of the trash can, because there'd be new cans issued that would be, given out to those customers. And when there's a workflow for that, so that gets captured in our GIS database now. So we could rerun this balancing if there was a significant change, right? So if there was especially if there was like a big development that went in, like there's a mobile home park in South Asheville that there are literally hundreds of trash cans there, right? Because it's a big mobile home park and each one has their own trash can. And it was one of the data problems we had. All those trash cans were associated with a billing address, which was not the physical address. So in this cleanup process, we had a huge bunch of cans that got cleaned up, and it would have had major impact on that one truck's route. So, but yeah, so we could rerun the redistricting over time. It wouldn't have to be done regularly, and the state legislature was kind enough to take away any annexation power. So, I'm joking. So we don't have to worry about that either anymore. So yeah.
What was the value of having your cans located versus just using physical address?
Because some of the cans we didn't have a physical address, right? So they are located. That's a good point. We don't literally have the trash can located somewhere, an XY coordinate for that can. It's associated with what we call our civic address IDs, which are unique address IDs. So each can is associated with an address. That's the geolocation of the can. So in this case, we had about 9%. We didn't have that association established. Does that make sense? Like there was a billing address, but not a site address.
Why you go that far as the geolocated can as opposed to just using the address?
So we are using the address. I'm sorry, that maybe wasn't clear. I think I misspoke there. It is the site address that the can's associated with. It's just for 9%.
Why don't you just ignore the cans and send a driver to every address?
Because some addresses have more than one can. Some there's commercial addresses that don't have any cans because they use like a waste management. But that's a really good question. But there are cases where we have some accounts where they have 3, 4, 5 cans. So you need to know that, right? Yeah. Okay. A couple more minutes of it. Yeah.
You said like they were all very efficient, the trucks.
Right.
So do they have longer workdays when you those two out?
So this does add a little bit more. That's a really good point. And I should say we are in the. This has not been implemented yet. There's been sort of some changes within the Department of Public Works. That is, we have a new director, and we actually have a presentation scheduled with part of the city's executive team in 2 weeks to present the findings. Like the sanitation people have known about this for months, but because of some changes internally, it's been delayed. But they're excited to implement. We just have to make the case now to the senior management team.
They're excited to have longer days.
Well, the management team, they were tasked. Well,
I was curious about that too. I want to know.
no, that's a real okay. Hold on. These people are good people, okay? They're not. Don't.
But no, I
That's-
think we are. We've been very efficient and very hard workers. I'm sold.
The managers were like the biggest advocates for these drivers, and what their charge at first was like, you all need. This came from the top. You all need to slash out some of these routes and cut back, and you need to make these drivers work 10 hours a day like we pay them for. That was the charge. And these sanitation guys who've been in the business for decades, it's hard because they're at a lower level and they can't really. There's politics involved, and they have a hard time saying, if we make them work 10 hours, they're going to work 12 hours, and you're going to pay overtime, and we're going to have bad service. So do you really want that? That's the message, right? So what we're able to do here is show this model of how long the collection time takes. What we don't have built in is time for lunch, time for breaks. We do add in, like at the beginning of the day, they have to set up, get their truck ready and prepped. At the end of the day, they have to clean the truck and get it back to the garage. So on average, it's probably going to be somewhere in the 8 to 9 hours. So they should still be able to get, and some drivers admittedly are faster than others. They're not all the same. There are some guys that are just slow and methodical. I wouldn't say slow, but they're more methodical. Some guys just bust it out. It's amazing to watch them. So I don't think the drivers will have too much of a problem. They should still be able to get off early, an hour and a half to 2 hours a day. But it's a good point. What?
Don't you think the time that you're saving for those positions is just from adding time to the other routes? It's not really from route changing the workload.
It's balancing the workload. That's right. It's through the balancing, you're basically making them all about the same. So you had some that were finishing a lot earlier, some that were taking a little bit longer. Now we're balancing, but sort of upping the ante a little bit.
Yeah.
You're right. No, I hear you. You're right. We'll see. The proof will be when this thing is fully implemented. So anyhow, I think I'm out of time. Thank you very much. If you have any questions, talk after.